In this problem, we're going to solve a two-block system. We got one block that's here on a ramp. The other block is hanging over the side. They're connected by a string via a pulley, which is right here. Our goal is to find the mass of the block, which is this one. Obviously, this one is given at 17. That will help this system remain in equilibrium, so it's not going to accelerate left and it's not going to accelerate right. To give ourselves enough room to solve this problem, I redrew this on another page. All the forces are drawn. So we have our 17 kilogram block here, and our hanging block here is the one we want to find the mass of. And then I drew on the block that's on the ramp my gravity parallel, my gravity perpendicular, my normal force, and the tension force that goes up the hill. On this block hanging off the side, I have the tension force up and gravity going downward. Typically, when you have a two-block system, what you want to do is not go with the normal positive is up and down and right and negative is down and left, but instead you want to take a look at how this system can move. If this hanging block goes upward, then this block is going to go down and to the right. If this block goes up and to the left, then this block is going to go downward. And when that happens, we want to make sure that our signs match up. So I'm going to say that any force that makes this system go sort of in a clockwise direction, so this block on the ramp will go down the hill and the block here will go up, I'm going to say those are positive forces. And any force that tries to make this block go up the hill and this hanging block fall, I'm going to say those are negative forces. Now whenever we have a two-block system, we're usually being asked about one or the other. In this case, we're being asked about the hanging block. When you're being asked about the hanging block, that's because you don't have enough information to solve right here. So what we want to do is we want to look to the block that's on the ramp to find some information that'll help us. And the only things they have in common are the tensions. This tension on the hanging block is equal to the tension on the block on the ramp. So if I can solve for this tension, I'll know what the tension is on the hanging block, and that'll help me out. So we're going to take a look at the block on the ramp to try and find tension. And that's in a left and right direction. So I'm going to look to my left and right direction. My components are done. Gravity parallel and perpendicular are already taken care of. So I can just add up my things going in the left and right direction. Force of gravity parallel would make this system go in a clockwise direction, so that's positive. And tension is going in the opposite direction, so that's going to be my negative force. I'm out of forces that go in the left and right direction on that ramp, so that equals 0. Algebra then tells me that the force of gravity parallel has to equal that force of tension. We have an equation for the force of gravity parallel, and that is the sine of the angle of the hill, which is given at 35, multiplied by the force of gravity itself, which is the mass of the block times 9.8. That's going to equal the tension right here. I can plug in my numbers because we have the mass of the block. It was given at 17. So I will plug in those numbers. I have the sine, 35 degrees. The mass is 17 kilograms. And the g is 9.8 meters per second squared. It's going to equal my tension. Plug in those numbers, and I get the tension is 95.6 newtons. I can now use that over here with this block. For this block here, I've got tension going upward. That's a positive force. Makes it go clockwise. Minus my force of gravity. I'm out of forces on that block, so that must add up to be 0. Again, algebra tells me they are equal to each other. And it's asking for the mass of this block. So when it's asking for the mass, I've got to use the equation. The force of gravity is m times 9.8. I'm solving for mass, so I divide my 9.8 over, and I get tension divided by g equals mass. Plug in my numbers, going to go over here. Tension was 95.6 newtons, and g is 9.8 meters per second squared. That's going to equal my mass. So when I plug in, I would get my mass is 9.8 kilograms. And from there, we're finished.